The Mars Helicopter Scout (MHS) is a planned robotic helicopter that will test the technology to scout interesting targets for study on Mars, and plan the best driving route for future Mars rovers. It is a technology demonstrator that will form the foundation on which more capable helicopters can be developed for aerial exploration of Mars and other planetary targets with an atmosphere. The small drone helicopter will be deployed in 2021 from the planned Mars 2020 rover, and it is expected to fly up to 5 times during its 30-day testing. NASA will assess whether this technology demonstrator can fly safely, and provide better mapping and guidance that would give future mission controllers more information to help with travel routes planning and hazard avoidance, as well as identifying points of interest for the rover. The project was funded $23 million in March 2018, and it was announced on the 11th of May 2018 that the helicopter can be developed in time to be included in the Mars 2020 rover mission. Topic: Development. NASA's JPL and Caltech have been exploring the potential of sending an airborne scout robot to accompany the Mars 2020 rover, publishing the conceptual design of this helicopter in 2014. The primary objective of this helicopter is to test the technology required to explore the terrain ahead of the rover to provide overhead images with approximately 10 times greater resolution than orbital images, and would display features that may be occluded from the rover cameras. It is expected that such scouting by small helicopters may enable future rovers to drive up to 3 times as far per sol. This helicopter will fly no more than 3 minutes per day at altitudes ranging from 3 meters to 10 meters above the ground, and could potentially cover a maximum distance of about 600 meters (2,000 feet) daily. It will use autonomous control and communicate with the rover directly after each landing. The helicopter will undergo a 30-day test campaign and fly up to 5 times early in the rover's mission, as it is primarily a technology demonstration. If it works as expected, NASA will be able to build on the design for future Mars missions. Mimi Ong is the project lead. Other team members are AeroVironment Inc., NASA Ames Research Center, and NASA Langley Research Center. Topic: Design. The helicopter uses counter-rotating coaxial rotors about 1.1 meters in diameter. Its payload will be a high-resolution downward-looking camera for navigation, landing, and science surveying of the terrain, and a communication system to relay data to the 2020 Mars rover. Although it is an aircraft, it is being constructed as a spacecraft in order to endure the G-force and vibration during launch. It also includes radiation-resistant systems capable of operating in the frigid environment of Mars. The inconsistent Mars magnetic field precludes the use of a compass for navigation, so it will use a solar tracker camera integrated to JPL's visual inertial navigation system. Some additional inputs might include gyros, visual odometry, tilt sensors, altimeter, and hazard detectors. It will use solar panels to recharge its batteries, which are 6 Sony Li-ion cells with a nameplate capacity of 2 Ah. The prototype uses the Snapdragon processor from Intrinsic with a Linux operating system, which also implements visual navigation via a velocity estimate derived from features tracked with a camera. The processor is connected to 2 Flight Control Microcontroller Units (MCU) to perform the needed flight control functions. Communications with the rover are through a radio link called ZigBee, a standard 900 MHz chipset that will be mounted in both the rover and helicopter. The communication system is designed to relay data at 250 kilobits per second over distances of up to 1,000 meters. The helicopter will be attached to the underside of the rover. It will be deployed to the surface between 60 and 90 Martian days after the landing, and then the rover will drive approximately 100 meters away for the test flights to begin. Topic: Status. By mid-2016, $15 million was being requested to keep development of the helicopter on track. By December 2017, engineering models of the vehicle had been tested in a simulated Martian atmosphere and models were undergoing testing in the Arctic, but its inclusion in the mission had not yet been approved nor funded. The federal budget announced in March 2018 provides $23 million for the helicopter demonstration, and NASA officials announced on the 11th of May 2018 that the helicopter was approved to fly on the Mars 2020 mission. Its mass is expected to be just under 1.8 kilograms, 4.0 pounds, and it will make up to 5 flights. The helicopter is currently undergoing extensive flight dynamics and environment testing. If the final testing goes well, it will be integrated with the Mars 2020 rover in mid-2019. Topic: Future. This technology demonstration will form the foundation on which more capable helicopters can be developed for more ambitious missions to planets and moons with an atmosphere. The next generation of rotorcraft may be in the range between 5 and 15 kg with science payloads between 0.5 and 1.5 kg. These potential aircraft could have direct communication to an orbiter and may or may not continue to work with a landed asset. Future helicopters could be used to explore special regions with exposed water ice or brines where Earth microbial life could potentially survive. Mars helicopters may also be considered for fast retrieval of small sample caches back to a Mars ascent vehicle for return to Earth. Topic: Specifications. Topic: See also: Dragonfly spacecraft, other proposed Mars aircraft; Aerial Regional Scale Environmental Survey (ARES); Sky Sailor.